Okay, today we're going to work on lesson 11. We're going to be adding fractions and we're going to be looking at inscribed angles. Okay, so think about fractions and what we know about fractions. If we're going to add a fraction, we have to have a common denominator. All right, so we're going to look here. If I've got m over x plus 4, and I want to add these, I look and I see that the first item is a fraction. Okay, the second one I can write as a fraction as well. All right, I need to add, in order to add these, I have to have a common denominator. So in order to add them, the first one's going to have to be something over x, and the second one is also going to have to be something over x. The first one is already m over x, so I can just keep it as that, right? The second one, in order to get it over x, in order to have that in the denominator, I have to multiply the 1 in order to get this right down here to be x. What do I have to multiply it by? I need to multiply it by x, right? So what I'm going to do here is I'm going to take this 4 over 1 and I'm going to multiply it by x over x. Okay, so I'm going to do this in order to get that common denominator. Therefore, I'm still going to have my m over x. When I multiply this second one, I'm going to get now 4x over x. So now I can add the two and I get 4x plus m over x, if I write that correctly. Okay, let's try another one. Let's see. Let's do something different. We'll change up our color here so we can tell the difference between the two that we did. Okay, so let's do 4 plus c over x plus cxy. All right, so that's going to be our original problem. We can think about this as 4 over 1. We can think about this as cxy over 1. All right, and remember, I want to have all of my denominators, they need to be common, and it looks like my common denominator is going to be x, okay? So I want to have my first term with x in the denominator, plus my second term with x in the denominator, plus my third term with x in the denominator. All right, so let's think about these. What am I going to have to do in order to make that happen? So with this first term, I have a 1 down there, so I'm going to need to multiply that by x over x, right? Second term already has an x down there. Third term, I'm going to need to multiply this by x over x. All right, so when I do that, my first term becomes, oh, I definitely do not want a ruler. That's funny. All right, ruler, go away. Okay, my first term becomes 4x. My second term is going to continue to be c. All right, and my third term is going to be c x squared y. All right. And let's actually change this up just a little bit. This right here, let's let this be subtraction instead of addition. Let's subtract that one right there. All right. So now all I'm going to do is I'm going to combine my like terms. So now I'm going to have 4x plus c minus c x squared y, and all of that is going to be over x. Okay. Let's do one more. All right. Let's pick a different color again. All right. Let's try one more. Let's say we have x plus x squared over y minus 3x over cy squared. All right, you're watching a video, so you could go ahead and stop the video and try to do it. Try to do it on your own and then come back, okay? All right, so let's think about what we're going to want here for our common denominator to be, right? We can think about the fact this is going to be over 1. We can see that we have a y here. We have a y here, but we actually have y squared, and we have c. So I think this one right here is going to be our common denominator. So we need to have cy squared plus a cy squared minus a cy squared. Okay. All right. Did you get that far? So there's your hint. If you haven't tried this on your own yet, why don't you go from there and figure out what your numerators should be. All right, so let's think here on this first one. I've got a 1 in the bottom, so I'm going to have to multiply this by cy squared over cy squared, right? This one right here, the second one already has a y, so I'm going to multiply it by cy. And then the third one's already good to go. All right, so with this first one, when I multiply top and bottom both by cy squared, I'm going to get cy squared x. All right, the second one, I'm just multiplying it by cy, so I'm going to get cy, and then there's already an x squared up there, so there's cyx squared. All right, and then the third one's already good to go, this 3x. Now all I'm going to do is combine my terms on the top. None of them are the same. The first term has a y squared and a single x. The second term has a y and an x squared, so I can't combine them. So the best that I can do is I can say cy squared x plus cy x squared minus 3x. And then all of that is going to be over cy squared. Okay? All right, so those are some examples there of what that is going to look like. Okay? All right, we are going to move on from that topic now. And now we're going to look at some angles. Okay? We're looking at the idea now of inscribed angles. All right, and inscribed angles are going to be angles that are inside of circles. All right, so let's have first, if I've got a circle, okay, there's that, and say I've got this, and I've got this angle right here. Okay, here I'm going to say that this angle here is 30 degrees. All right, if that angle there, this is going to be called a central angle. Okay, with this central angle, my vertex is at the center. Okay, and I want you to notice also that my sides of this angle are each the length of a radii. So my sides are equal to the radii. All right, so with this, when I've got this, my angle is going to be a central angle. It's right there at the center. My vertex is located there at the center of the circle. And my radii, my sides are going to be the length of a radii. Then I've got this arc right here that winds up being intercepted. In this case, the measure of that arc is going to be equal to the measure of the angle. All right, so when I have an angle that is located at the center, the vertex of the angle is at the center of the circle, then the measure of the arc that is created when the sides of the angle intersect the circle, that measure of that arc is going to be equal to the measure of that angle. Okay, so the angle measure is going to equal the arc measure when I have a central angle. Okay, when the angle, well, let's say the vertex, is central. All right. Now what we're going to look at next is when I've got my angle being actually on the circle. So here, if I've got this right here, and I have an angle like this, okay, and it's opening way over here. So it's my vertex is way over here on the side. Okay, my vertex is on the side of the circle. My sides here are not equal to a radius. Okay, so here my vertex is on the side of the circle. My sides are not equal to the radii. Okay, so here I'm going to have this being, say this is the same amount of distance over here. This over here is 30 degrees. This over here is just 15 degrees. Okay, so here, when I've got this inscribed angle and it's on the side, the angle of the vertex equals 1/2 the angle of the arc. All right, so if the vertex is at the center, then the angle of the vertex is going to be equal to the angle of the arc. If the angle is over here on the side, if the vertex is over here on the side, then the angle of the vertex is going to be half the angle of the arc. All right, so that's not bad. Let's do a few problems with that. Let's do a couple of things with it. Let's look also at another idea for us real quick, though, actually. If I've got a circle, and here's the center of the circle, all right, and say I've got this line going right through my center, all right, I have another line going here, and then I have this line going right there. All right, and with this right here is a 90-degree angle. All right, this is a 90-degree angle. This right here is a diameter. All right, so notice that's a diameter, and that's also the hypotenuse of that triangle. Okay, so I've got that hypotenuse is also a diameter of the circle. Okay, well, I want you to notice there that with that, I've got an angle, and this angle, the vertex is over there on the side. Okay, and we said that when my vertex is over there on the side, that the angle of my triangle, that angle there at the vertex, is going to be half of the angle of the arc. Okay, well, here's this arc that I've got going here. Notice, where the where this intersects right here. It intersects there and intersects over there. So notice this is coming through here. This is coming through here. This is 180 degrees over here, where the diameter intersects both sides of the circle from one side to the other is going to be 180 degrees. All right, so I've got 180 degrees there. Therefore, I can know that this arc over here, this angle over here, has to be 90 degrees because 90 equals half of the 180, right? 180 divided by 2. All right, so I've got that. So when I have a circle, I have this right here coming through right here, okay? It's when I've got this triangle and the sides of the triangle are intersecting my circle right there at an actual diameter, then I know that this right here is going to be a 90-degree angle. This is going to be 90. This over here is going to be 180 from here to there. Okay? So that's kind of an interesting thing. That's kind of cool looking. Let me draw you another circle here. All right, say I've got Or do this kind of big. I wish that it was a prettier circle. All right, say that I've got that. I have this right here going through. We'll pretend that that's the center, okay? And say I've got this right here. Okay, and I have this right there. Okay, what we want to do is this over here is angle A. This over here is angle B. And we are told, let's see, this is going to be C. This is going to be D. And we are told that this arc out here is 60 degrees. And we want to solve, we want to figure out A, B, C, and D. All right, so let's think about that for a little bit. All right, so if the arc equals 60 degrees, if that arc equals 60 degrees, then A has to equal 30 degrees because we know that A is half of 60, right? So we can come over here and we can plug in that this right here is going to be 30 degrees. So A is 30 degrees. All right. Now let's think about this right here. I've got A being 30 degrees. Look here, what else we can think about. Think about these sides of my triangle. If I look at this triangle right here, I've got this and I've got this, right? This right here is going to be a radius and this right here is going to be a radius, okay? So here's that triangle. It's looking like this. It's got this one. It's got this one, okay? Here's C. Here's my A that's 30 degrees, all right? And I know that this is the length of a radius and this is the length of a radius. Therefore, I know that this side of the triangle is equal to this side of the triangle, all right? Well, there's a base angles theorem, and what we know is that if the two sides are equal, then the two angles are going to be equal. So because this side over here equals this side, then this angle over here is going to equal this angle over here. Therefore, I can say that if angle A equals 30 degrees, then angle B also has to equal 30 degrees. Okay, so over here B is going to be 30 degrees. Okay, and angle A is 30 degrees because the arc is 60. Because the arc is 60, we know that A is 30. Because the two sides of this triangle are both these radiuses and they're the same, we know then that angle B has to also be 30 degrees. Okay, now think about this. Here's this whole triangle here, right? I've got this triangle right here, and I've got those two angles are 30 degrees, right? So I've got that A plus B equals 60 degrees. Well, I know that the whole triangle has to be 180 degrees, right? So if A plus B equals 60, then C equals 120 degrees, right? Therefore, C is going to be 120 degrees. All right. We also can know, we can think about D, and we can think about D two different ways. For D, we know that this angle over here, this arc is 60. If that arc is 60, then D has to equal 60 degrees, right? We also know that D plus C have to equal 180 degrees because D plus C, we can see they make a straight line right here, right? Therefore, D plus C has to equal 180. And so we know that C is 120. Therefore, D has to be 60. Or we could look at the idea that we know that D is 60 because of this angle, because of that arc. Therefore, D has to be 60. If D is 60, C has to be 120 because D plus C have to equal 180 degrees. All right, that's just kind of fun to see how you can figure all that out, how all of those relationships go together and let you come up with that. Oops, touch my thing. All right, let's look at one other thing real quick. We're actually going to look at the same thing, and I want you guys to try it on your own a little bit. Okay, I'm going to give you your own circle here. All right, so here, if I've got this circle, boy, I wish that I was better at that whole circle thing. They just do not look pretty, do they? Let's see if I do that. Will that make a pretty circle? Oh, look, it'll make it. That's okay. Oh, I can draw on it too. Okay. Don't laugh. I'm laughing. It used to be. See, there we go. So it used to be that you could draw something and it would just automatically snap and it would make it pretty. And that's not as automatic as it used to be. Okay, so see, look at that beautiful circle that I have now. Isn't that lovely? All right, so say we've got that, and I'm going to have this line that's going to go across it there. Okay, and I've got this line that's going to come into it right there. And then we're going to have this line over here. And I'm going to tell you that this is 150 degrees. All right. This over here is D, that arc. This angle down here is going to be C. This angle over here is B. And this angle over here is A. So, can you find A, B, C, and D? All right, and you're given that one angle is 150 degrees. Go ahead and pause the video and do it yourself. Okay, work on it on your own. Okay, I am assuming that you did this on your own. So let's look at some things here. Let's solve this one differently than we did the last one. We can start this time with even just looking at this. Okay, here I've got that straight line, right? So if I've got that straight line, I know that this has to be 180 degrees. Therefore, that has to be 180 degrees. I know that the one angle is 150 degrees. So that's going to leave me 30 degrees for angle C. Okay, so angle C is going to be 30 degrees. Good. All right. If angle C is 30 degrees, then D is 30 degrees because angle C is a central angle. We've got that right there at the center. So that arc D is also going to be 30 degrees. Okay. Remember, let's look now at this last triangle that we have over here. Let's look. Where am I looking at? This right here. Bing, bing, bing. All right, even though it doesn't look great in my drawing, remember this is what it kind of looks like. I've got this and this. I know that this is 150 degrees, right? I also know that this side right here is equal to this side right here. And seeing as those two sides are equal, these two angles are equal. I know that the whole triangle has to equal 180. I've used up 150, so I'm left with 30 degrees, right? So I'm going to take that 30 degrees, I'm going to divide it by 2, and I'm going to say that each of those other angles is 15 degrees. All right? All right, great. If you have any questions, give me a holler. You know where to find me. I hope that you have a great week and a great time with your